We said we were going to start with the absolute value of 3 minus. Today is the 2nd, isn't it? Okay. So I have the absolute value of 3 minus x minus the absolute value of 2x plus 4. Okay. How do I start? What is the first step?
3 minus x if x is greater than or equal to 0.
Which translates into x less than or equal to 3. We know that. Do I have to show anything here? No. Okay. What about the other option? Careful. That was what you. I think you wrote 3x. That's why that messed you up.
No, I think
Okay.
I just forgot to.
Okay.
So negative 3x plus x.
Good. I don't have to solve anything. It has to be the opposite. Good. And now 2x plus 4. Same thing. So I have 2x plus 4 for x greater or equal to negative 2. Yes, please.
So how do you get the opposite? Because
You're talking about this?
yeah. Well,
Okay.
So I know you.
So are we talking? Hold on, Shane. Are we talking about this?
No, we're talking about the one below.
Oh, sorry.
So it's negative 3x plus x if x is less than or equal less than 3.
You mean this one?
Yeah.
This one is to the left of 3.
Yeah. So you.
Can this one be to the left of 3?
No.
No. So it has to be to the right of 3.
Oh, okay.
But if you want to solve it, you can.
Well, if you
What will you? Yes, 3 minus x. Yes, less than 0, and you get x greater than 3. But if you remember, I said don't waste your time with the second one. Once this one is whatever direction, this must be the opposite, and without the equal symbol.
So when you saw that, when you do minus 3, and then you would have that.
You mean this one or this one?
That one.
Okay, let's do that. So 3 minus x less than 0. I move 3 to the other side.
Right.
Negative x less than negative 3. How do I solve this?
So negative.
Divide or multiply by negative 1, x, and 3. What do we have to do when we solve an inequality and we multiply both sides by a negative number? Right. So that's how we get this. Are we in agreement now? Is this okay? Everyone?
Because you pulled a negative 1 out to begin with to make it 3 minus x.
This one? Okay, so let's go back even further.
But it only tells like when you make a new problem, it's negative 3 plus x. So if negative 3 plus x is, and that means x is.
Okay, we have to go back. Hold on. So if I have this, remember, so this is 3 minus x. This is 3 minus x. This is 3 minus x. This is 3 minus x multiplied by negative 1. And this is 3 minus x. All these 5 have to be identical. The only change is here. Right? So I can't change anything. It's 3 minus x greater than or equal to 0, 3 minus x less than 0. This is carved in stone. That's why I said, in order not to get confused here, remember, if this one is less than or equal to 3, this one has to be greater than 3. Done.
Okay. I see it now.
If this one is greater than 5 or equal to 5, this one will be less than 5.
Okay, I got you.
So, because then we get into confusion and then we mess up.
Yeah.
Okay? So, is the second one clear so far?
Yes.
Okay, so then negative 2x minus 4, x less than negative 2. I don't have to do anything. If this one is greater than or equal to negative 2, this must be less than negative 2. Are we in agreement now? Everyone? Andrew? Yes? Okay. Good. So then my next step is to collect the information I have and then make a decision later, right? Okay. So if you're using my method, you don't have to. If you're using my method, this is what I recommend. So 3 minus x, and then 2x plus 4. And then what I'm interested in? Well, what I'm interested in is 3 minus x minus the absolute value of 2x plus 4. Agreed? Okay. So then what numbers go in the x values between negative infinity and infinity? Of course. And they have to be in ascending order. Otherwise, I mess up the whole thing. Okay, So now I read. Here's what I have. The absolute value of 3 minus x can be replaced by 3 minus x every time I have an x less than or equal to 3. So where will I plug in or put 3 minus x? In my first row.
To the left.
To the left of 3. So I have two options here. And here's my third option. I read again. The absolute value of 3 minus x can be replaced by negative 3 plus x for any x value to the right of 3. What do I do? That's it. So I'm done summarizing the information coming from the absolute value of 3 minus x. Now the second one. The absolute value of 2x plus 4 can be replaced by 2x plus 4 for any x value to the right-hand side of negative 2. In how many subintervals will I put 2x plus 4? 2. So this one and this one. And finally, I read again. The absolute value of 2x plus 4 can be replaced by negative 2x minus 4. And how many subintervals do I use this for? Now, remember, I'm asked to subtract. So I have to be careful how I do that. So I have 3 minus x, the opposite of negative 2x, and the opposite of negative 4. So plus 2x plus 4. I perform the calculations and I get x plus 7. Is this clear, everyone? Okay, in the middle, I have 3 minus x minus 2x minus 4 because I have to distribute negative 1 to the second piece. And the answer is negative 3x minus 1. Are we in agreement with negative 3x minus 1? Okay, finally, negative 3x, negative 3 plus x minus 2x minus 4, and I get negative 3x. I'm sorry, of course. I get negative x and then minus 7. Are we in agreement with negative x minus 7? Is that a yes? Is that a maybe? Okay, perfect. So now, final question, what is the answer? How do I write the final form? So I write the absolute value of 3 minus x minus the absolute value of 2x plus 4, and I have how many options? Yes. What is the first option? Yes, no. The answer is x plus 7 if x is, if you want, less than or equal to negative 2, that's fine. As long as you don't put the equal symbol in more than one spot for negative 2 and 3. And the second portion, negative 3x minus 1, if what? Negative 2 less than x. Now you decide. Is it less than or equal to 3 or less than 3? Doesn't matter. You want less than 3. Perfect. And the last option is negative x minus 7 if what? Exactly. Any questions? Okay. Can we move away from this particular type of problem?
Yes.
Are we done with that? Okay. Hi, Nick. Are you okay? I'm sorry to hear that. Okay. Thank you. Okay, so we are looking at, this is for you.
Oh.
So take one each and study them. If you're interested in any of that, just go ahead. Bye. Okay, so 3 divided by x minus 1 greater than or equal to 1. What do I do? No, I cannot multiply both sides by x minus 1. Not allowed. So that's not an option. So what do I do? I have to. Then? Yes. Which is? Yes. Then adjustments. What do I need for the top of the first fraction? Exactly. What do I need for the top of the second fraction? Indeed. So now please, anyone dictate what I have at the top. 3 minus? Very good. I distribute negative 1 to x, and I distribute negative 1 to negative 1. Good. Let's combine like terms at the top. divided by x minus 1. Nothing goes away. We know that. And again, I recommend the following chart for studying the sign of this expression. X is the variable in the problem. Negative x plus 4 is the first factor. X minus 1 is the second factor. And what we're interested in is this. Which x values go in the top, at the top? And why? Okay, 4 and 1. They have to be in ascending order. So from left to right, what do I put?
1.
Okay, 1 first and 4 from the second. So 1 from here, 4 from here. Good. I must have what in the row of negative x plus 4? Somewhere. Where? On the 4, of course. What do I have? What happens in the row of x minus 1? Right, at 1. Good. Now I have to decide what happens to the whole thing, which is a fraction.
So 1 would be under 5.
Exactly. Thank you very much.
And 4.
Excellent. Do we all agree, everyone? Nick? Okay. Good. So now what next? What happens next?
You draw the sign.
Yes. So what are the signs for negative x plus 4?
Negative goes from 0 to 5.
Let's think.
Oh, it's positive and then negative.
Exactly, because it's a negative slope. Do we all agree with positive and then negative? Everyone. Chris? Agreed? Agreed?
Yeah, but I multiplied by -1 before.
That's good. That's good too.
Okay.
So you solved x minus 4 over x minus 1 less than or equal to 0.
Yeah.
Excellent. And you get the same answer.
Okay.
You did very well. Because you didn't want to mess with a negative leading coefficient.
Yeah.
I tortured you well last semester. Good. Excellent. So what about the signs for x minus 1?
Negative, positive.
Right. We're multiplying or dividing a positive and a negative on the first subinterval. Two positives.
Positive.
And finally, I go back to my question. Which sign is greater than or equal to 0? And there is only one. Which one?
1 and 4.
Yes. So how do I write the solution? X in the interval, what?
Parentheses 1.
Right. Why parenthesis?
Because you can't.
1, of course, undefined. Comma?
Bracket 4.
Excellent. Wasn't that hard, was it? So I would make myself a note somewhere. Do not multiply both sides of inequality by x minus 1. Okay? Good. So let's look at problem 8. Here's our function, f of x. Any questions before we do that? So please, if you make that mistake, please make yourself a note. Never multiply both sides of an inequality by x minus 1 unless you know it's always positive and never 0, blah, blah, blah. But they're under specific conditions. So I'd rather say don't before you look at the problem carefully. Okay, we're asked to find the domain of this function. How do I start? What do I have to do? I can't. I have to state something before.
X cannot be.
Not x. There is no radicand of x here. I don't see a radicand x, so I can't say x yet. If I had that, I would have said this, but that's not what I have. So, what do I have to write?
F of x must be greater than or equal to 0.
Nope. What kind of radicals are these?
Right.
They are square root, right? What is the index, in other words, I'm asking? 2. Good. So whenever we have a radical with an even index,
X has to be positive.
not x,
Positive.
but this
Square root of x.
has to be positive or 0 unless it's in the denominator, so when, situations are more complicated. So then what do I have to write?
Square root of
There is no square root. When I state the domain, I have to state a restriction on the quantity under the square root, not on the square root. I know the square root will be positive if it exists. So what do I have to write? What is the condition for this to be a real number?
It's gotta be greater than 0.
What? Greater than or equal to 0. What has to be greater than or equal to 0?
X squared.
Right. Yes, of course. So this will exist if x squared minus 9 is greater than or equal to 0. Now about the second one. So we have two conditions here then. What is the condition for the second one? X plus 7. It has to be greater than or equal to 0. Good. The second one I know how to solve. It's a blink. And what do I do? So what do I have to write?
X is greater than negative 7.
Okay, so what do I do with this? Remember, I cannot move 9 and take square roots. That's not allowed.
Oh, you factor
Yes, I have to factor. So I have, how do I factor it?
X plus 3 and 5.
Yes, we have an agreement on that, right? Good. Now, you have several options. If you want to stick with my chart, please do so. If you have another option, use the other option. I'm fine. So here's my chart. I'm studying the sign of these and, of course, the product. Which x values go in the chart at the top?
Negative 7.
Okay, this is done. This is linear. Inequality. We never use the chart for a linear inequality. There is no need. It's already solved. We use the chart for rational. We use the chart for higher degree polynomial inequalities, but not for linear.
Negative 3 and 3.
Exactly. That's all we have. I'm only studying the sign of this product. Negative x plus 7 is not part of this product.
Okay.
Right? Is that clear? Okay, so then I have negative 3 and 3. I have to have some zeros somewhere. Where?
Negative 3,
And where?
3,
Okay, and then what is the product?
it's undefined,
Can a product be undefined? No.
sorry.
That's a-
0 and 0.
0 and 0. Both are linear functions with what kind of slope? Okay, so then the sign will be,
Plus, 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 minus, minus, minus.
careful, positive slope looks like this. Where does it come from?
Negative,
Negative slope looks like this. Is it positive or negative slope?
it's,
Good, so what is the sequence of signs?
negative, 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 plus, plus.
Very good. In both cases. Or you plug in a number. If you forget, plug in a number. Let's plug in negative 10. What will be the sign? Plug in negative 10. What will be the sign?
It's a negative,
Right. Plug in 10. What will be the sign on this portion?
positive.
Good. In case you forget. Okay, so now I have 3 subintervals. Sign on the first one, please. Second one, and last one positive. Now, tell me what I have to write. What sign is greater than or equal to 0? What do I pick?
Negative infinity, negative 3.
Negative infinity to negative 3, it includes 0. So x in the interval. Union, what? Is this sufficient? So we solved a condition for the first function. We solved the second condition for the second function. What do I do now? In order to find the domain of function f of x, which is a difference of 2 functions. How do we call that? What am I trying to determine now for these 2 functions? How is it called? The blah, blah, blah domain. Nope. What word am I missing? Thank you. Thank you. Thank you. It's the common domain. Very good, Chris. So let's find the common domain. So let's graph it on the real line or the number line. From negative infinity to infinity, 0 in the middle. You know I don't care for units when I have to determine the domain. You can be very exact if you want to. So let's graph this one first. X greater equal to negative 7. So here's my negative 7. Where do I go? To the left or to the right? To the right. So the bracket, I go to the right. Good. So that's the first, that's the second, actually, for the second function. Okay, what about this one? So here's my -3. Here's my +3. And I show -infinity to -3. And I show 3 to infinity. And Chris said, find the common domain. So I would like anyone to tell me what to write. It's the domain of function f.
Bracket -7, bracket -3, bracket 3.
Do we all agree with this? It's where I see brown and orange. And here's where I see brown and orange. Here, brown and orange, brown and orange. This is brown, and this is only orange. So both of them have to exist at the same time for the function to exist. Okay, are we done with this? Oh no, we have the piecewise-defined function, and that's it. Okay. I know you also wanted the problem 14, which is the inverse function. We can do that too. But I'd like to start chapter 3. So in 5 weeks, and that's a bad reflection on myself as well. In 5 weeks, we accomplished 2 chapters. I have 10 more weeks left to finish 8. So I need your help. Okay? Good. So let's look at the piecewise-defined function. So f of x. So it's x squared minus 4 for x less than 0 and -x plus 2 for x greater than or equal to 0. I'm asked to graph this function, find the domain range, and so on and so forth. What is the first thing I have to find whenever I'm asked to graph a function? I want to hear everyone say that at the same time.
The range or domain.
Exactly. That is the starting point. I have no clue what to do before I find the domain. Okay. Are you with me, everyone? Okay, so what does this mean? In interval notation, I want a translation for this.
You only want the
-infinity to 0.
Excellent. I want a translation for this. In interval notation, please.
At 0 to infinity.
Very good. Now I would like anyone to establish the domain for this function, please.
-infinity to 0, union 0. Oh, wait.
Exactly. I completely agree. All real numbers. Everything is there. To the left of 0, 0, and to the right of 0. Do we all see that? Okay, good. So I get my chart going. -infinity to infinity. What must go in the chart even if I don't want it to be there? 0, of course. Why? What happens at 0? Yes. One function ends and the other one starts, right? And they both make up the same total function. Okay, perfect. So remember what we do next. Can anyone refresh our memory? What do we do next? Yes. So I see this symbol to the left of 0. I see this symbol, which is a bracket, touching to the right of 0. Okay. That tells me a lot about the function already. Which branch will I use? Which function will I use for -infinity to 0? I know it's there. I want to write it one more time. Right. What type of function is this? Right. We know how to graph a quadratic function, right? Okay. What about this one? From 0 to infinity, what branch do I use? I know it's silly, but I have to write it. Right. Are you with me so far? Okay. So let's look to the left-hand side of 0 and find a couple of ordered pairs. Do I know how to graph, before you even say anything, do I know how to graph the entire function x squared minus 4? I know the base function, and what do I do to it? Down 4, right? But in this case, it's only to the left-hand side of 0. So it's only going to be this, right? So let's at least look at -2. So let's plug in -2. Why did I choose -2 and not 5?
It's smaller. Easy to grab.
No, it's Because it's the x-intercept. Right. So what do I get?
0.
Yes. Good. Let's plug in 0. And you should say no, right? I'm not allowed to plug in 0 in this, but I will still do it. Why am I doing it?
You just need that.
Exactly. I will leave it as an open point. So please plug it in.
84.
Good. So now on the other side, please plug in 0.
2.
Yes? And plug in which number? Give me a number that will either give us the x or the y-intercept. Yes, of course. So what do I get? Okay, ready? Good. So let's graph this function. Good. First ordered pair from left to right. What would you tell me to plot? Okay, indeed, -2, 0. I need a different color. Okay, -2, 0. Then the next.
0, -4 with open diagonal.
Open point. Very good. Here it is. And I know how to graph this function, right? It's quadratic. And here it is. We graphed it in chapter 2. Okay, next.
0, 2.
Okay, 0, 2. Is it a full point or an empty point?
Full.
Right. And then,
2, 0.
what type of function is this? Right. So that's all I have to do. Okay, now let's also establish the range of this function. We have the domain. What about the range? Look at those arrows, and what will you say about the range of this function? Yes. Okay. Okay, is there anything else here? Do you, or can I start chapter 3? Want to do 14 and then stop chapter 3? Yes? No? Okay. Last one. So we have f of x, which is x squared minus 4, and we are told, why are we told x greater than or equal to 0? I'll ask you in a second after we read the problem. Find the domain and range of both functions, find the inverse, and then graph both functions on the same coordinate system. Okay, so why do you think the domain is truncated? It's minimized or reduced to 0 to infinity?
Because a full quadratic doesn't have an inverse.
It's not, exactly, because it's not 1 to 1.
Yeah.
Correct, very good. So now, remember the way we write domain and range. It's another simplified way. So the domain, we wrote this together when we looked at the inverse functions. F is a function f is defined on A, taking values in B, where this is the domain and this is the range. Now, can anyone tell us, because we know the graph, you can picture this in your head already. Can anyone give us the domain of this function, but keep in mind the restriction? What will be the domain?
0 to infinity.
Correct, excellent. Now you picture already this function in your head, please tell me the range.
-4 to.
Right, excellent. -4 to infinity. Now, I have no idea what the inverse function is, but I can determine its domain and range. Can anyone tell us what is the domain and what is the range of the inverse function that we don't even know what it is and how it looks like?
The domain is -4 to infinity.
Right,
And the range is
right. Excellent. Absolutely. And now we are ready to, and this will be our condition. We have to stick with this. That's why when we talked about it at the beginning of the class, remember, we said you have to put plus or minus, and you have to decide based on what you already have. You have to decide which one it is. Good. So now what are the steps of finding the inverse of a function that is 1 to 1?
so you write function. And then so you plug,
So
switch
y equals x squared minus 4 is the first step, yes?
and then you switch y and x.
Okay, x equals y squared minus 4.
The solver at y.
Yes, and I add 4, so I have x plus 4 equals y squared. And now please remember, we talked about this, taking square roots. So when I take the square root from the right and the square root from the left, what do I get? I get that y equals, and this is crucial to remember,
Plus or minus.
Yes, I have to write plus or minus. Yes. And then think, and then decide. Because the question here is which one? You cannot have two, because it's one-to-one. If a function is one-to-one, its inverse is one-to-one, and you cannot have more than one, of course. So which one will be f inverse of x? Right. How and why? Look at the range. I cannot have a negative in front. I know that this number is always what? What type of number is always the square root? Positive. But if I have negative in front, the range will not be 0 to infinity. It will be negative infinity to 0. And of course, the domain makes sense. What is the domain of this function? Just careful. We just had that. Again, the square root. It's going to mess us up forever. I hope not. So what do I have to write? No, we did not write the square root. X plus 4 has to be? Exactly. So x plus 4 greater than or equal to 0, and then I move 4 and I get this. Is that clear? Okay. So therefore, I will say no, only the square root of x plus 4. And that's the inverse function. And of course, the domain is x greater or equal to negative 4. Now, was anything on this test that we did not cover in class? Okay, I did promise to give you a bonus of 5 points because we had an agreement. So I will add 5 points to all your test grades. Happy? Good, me too. Okay, anything else? Do you have other questions for me? Other questions? Okay, chapter 3. Polynomial and rational functions. Polynomial and rational functions. We do know 3 polynomial functions. I need a list from someone. We already know 3 polynomial functions. Functions known already. Yes, linear, very good. We know linear. Quadratic. And we know one that we said it was odd, and we used it to show the relationship between the function and f of negative x for odd functions. What was it?
Rational?
Nope. We did not use that. Rational is not polynomial, but you're right. It's odd. Which one?
Absolute value.
Nope. It's this one.
Oh, the first cube.
X cubed. Very good. So the cubic function. So we do know these already. Of course, we're going to talk about them again. But not linear. I refuse to talk about linear. Done. Okay, so let's start with quadratic. Quadratic functions. They can be given to us in 2 forms. So f of x, ax squared plus bx plus c, that's one form. And the other form, f of x equals a, x minus h squared plus k. Let's talk about the first one first and the second one afterwards. So a, b, and c are real numbers. However, a cannot be, what do you think?
Zero.
Yes. Why a cannot be 0?
It would make it non-existent. Make it a linear function.
It will make it a linear function, exactly. So ABC can be any real number except for a 0. Okay, let's look at a function. Let's say a simple one, x squared minus 6x plus 8. Is this quadratic? Yes. Perfect. Okay. Let's suppose I'm asked to graph it. before we even talk about polynomial functions or graph this function, we have to establish what is the domain of any polynomial function, unless it's for whatever reason restricted.
Negative.
Right. So domain negative infinity to infinity for all polynomial functions. Again, unless there is a certain target and the domain has to be restricted. Perfect. I recommend the following 6 steps in graphing a quadratic function. Number 1, the shape. First of all, we know, yes. I thought we discussed that, but you're right, I should mention. The graph of a quadratic function, although we know, let's write it one more time. The graph of a quadratic function is a, yes, indeed, a parabola. We know that. Okay, so any parabola can have how many shapes? Right, opening upward or opening downward. Now think in terms of transformations. What will make a function like x squared not opening upward but opening downward? Negative in front. Exactly. Good. So then what about this one? Since it has positive leading coefficient, would it look like this? Or it will look like this? First one. Okay, perfect. So because the leading coefficient is a positive number, the parabola will have a minimum. And we always go back to chapter 2 and relate it to x squared because we graphed x squared in transformations. Are we all in agreement? Yes? Nick, are you okay? Okay, so step number 2. Any parabola, opening upward or downward, it doesn't matter. In this case, it has a minimum. If it's the other way, it will have a maximum. Regardless the name of that point, either minimum or maximum is called vertex. So that point is called vertex. Either a minimum or a maximum, vertex. We can go behind what we're trying to do here and try to find the coordinates of the vertex. However, I would rather give them to you right now because we are so far behind. So the x-coordinate of the vertex, if the quadratic function is given in this form, of course, that's what we're talking about. This will have to wait for a minute or two, is negative b over 2a. What is b? What is a? What are these numbers? Right, exactly. B is the coefficient of x, and a is the leading coefficient. Okay, perfect. Let's determine this for our function. Negative stays outside, and then b is for our function. Good. And the denominator is 2 times a, and a is what for our function? 1. So then the x-coordinate of the vertex is? Careful, there are 2 negatives in there. Yes, 3. Negative coming from the formula and the negative coming from the coefficient of x. Good. Now what do I do to find the y-coordinate? So right now I know where the vertex is found. Where? On what vertical line?
X equals 3.
X equals 3. Okay, now how do I find the minimum, right? We're looking for a minimum because it's this shape. So how do I find the minimum of this quadratic function? Yeah, how do I find that? Do I plug in 5? Do I plug in 0? Or how do I determine the y-coordinate?
Well, the parabola itself, x squared starts at 0. So
Nope. Nope. If I have the x-coordinate, how will I determine the y-coordinate of any function?
How do you put it
Exactly. What am I plugging it in?
in? F of 3.
F of 3, indeed. This must be, indeed, f of negative b over 2a. Perfect. So I go back to the function, and I plug in 3. And that's my vertex. So I have 3 squared minus 6 times 3 plus 8. So I have 9 minus 18 plus 8. So it's negative 17 minus 18. I owe you $18, and I say, Nick, I only have 17 today. So I'm still in minus with 1. So then one more time, the vertex for this function is? Good. Now in step 3, I will try to find the x-intercepts, comma, if they exist. What is this? What is this if they exist? What does that mean? Yes, it may not touch the x-axis. It has a minimum, but it may not touch the x-axis at all. So then the x-intercepts will not exist. Perfect. So here are the 3 possibilities, right? For a minimum, a quadratic function can do this. Can do this as an example, can do this as an example, or it can do this. Nothing else can happen here. I don't want to waste my time, meaning I want to look at this vertex and I want to be able to say it's this or this or this. Because if it's this, I don't want to waste my time. The x-intercepts don't exist. If it's this, the x-intercept is the vertex. No question about it, right? And if it's this, then I have to find 2 x-intercepts. This doesn't really look symmetric. Sorry about that. So it has to be symmetric, and I'll get to that in a minute. It has an axis of symmetry that has nothing to do with odd or even functions. Okay, so how do I know whether it exists or not? Where do I look? I look at the vertex. Exactly, exactly. The y-coordinate is a negative number. So is it this, this, or this if the y-coordinate of the vertex is a negative number? The third one. So therefore, I have to find them because they exist. I can't say, oh, they don't exist and move on. Okay, how do I find the x-intercepts for any function? Right, thank you very much. Y equals 0 indeed. So I have the function is, I turn my page, what was it? It's x squared minus 6x plus 8 equals 0. Perfect. So now what? How do I solve for x? Yes. Yes. Is it clear why I cannot move 8 or do any of that? Because it's what type? Yes, specifically what type? Quadratic. Okay, in polynomial, you're right. So can anyone give us the factor form of this?
X minus 4, X minus 2.
Exactly. X minus 4, X minus 2. So I do have 2 options. And what are the options?
4 and 2.
Very good. Which means what ordered pairs are we talking about?
Oh, so X, 4, 0.
Exactly. Do we all agree with 4, 0, 4, comma 0, and 2, comma 0? Yes? Andrew, are you okay? Good. So step number 4, the y-intercept, which will always exist in this particular, for polynomial functions. What is it?
F of 0.
F of 0 indeed. How much is f of 0?
Let's see. 8.
Exactly. So which ordered pair did we just find?
0.
Very good. Okay, so let's look at 5 and 6. Okay. We already know that x squared is what type of function? Symmetry-wise? Even, meaning x squared is what? Symmetric with respect to?
Negative.
X squared is symmetric with respect to if it's even. Symmetric with respect to just x squared. Just x squared with respect to the y-axis. Correct. Very good. So any quadratic function is a symmetric curve. The axis of symmetry is not part of the graph, but we will graph it as a dashed line just to help us keep the graph in shape, because it's symmetric. It has to be symmetric with respect to the axis of symmetry. They're not symmetric in the sense of odd or even, other than x squared. Okay, I may encounter other quadratic functions that are indeed symmetric with respect to the y-axis, but not in this case. When it crosses at 4 and 2, it cannot be symmetric, either odd, or even, which is symmetric with respect to the y-axis. Not possible. So what is the axis of symmetry? Is the vertical line passing through the vertex. Exactly, you already said that. Very good. X equals 3 indeed is the axis of symmetry. Now finally, I want you to tell me, since it has a minimum or a maximum, one more time. Minimum. I would like you to identify the minimum of this function. The minimum value of f of x is. What is the minimum value?
-1.
Exactly, -1. Very good, both of you. Okay, I'm ready to graph. We always start with a vertex. Again, what is the vertex? We continue with the axis of symmetry, which is not part of the graph of the function, but it will help me keep the graph symmetric with respect to this line, x equals 3. I need the x-intercepts, which are what? Very good. Notice 1 second, let's stop for a moment and let's look at these two x-intercepts. Are they symmetric with respect to the axis of symmetry?
Yes.
Yes, 1 unit away from the axis of symmetry. Okay, and finally the y-intercept. Do not graph it too acute. Graph it as symmetric as possible. I promise I will not look with a magnifying glass. My graph is not perfect either. But just make sure that it looks as symmetric as you possibly can. Always write the name of the function. This is a function x squared minus 6x plus 8. Anywhere on the graph, left, right, under the graph, wherever. So now, without even graphing it, without even looking at the graph, can anyone picture this in their head and say, I know the range is blah? Right. -1 to infinity. Okay, let's look at the other shape. Not shape, the other form of the quadratic function. And then I'd like to look at some word problems. There are a lot of applications here. A lot of model, real-life situations can be modeled using quadratic functions. So let's look at the other one. So let's say f of x equals negative x plus 1 squared. Let's say minus 4. Okay. Is this of this type? Can anyone identify the leading coefficient? -1. Can anyone identify carefully h? Careful. -1 indeed. So yes, indeed, h. -1. Can anyone identify k? -4. Write them on the side and leave them alone for a second. Now, I would like you to tell me, what is the base function here? Okay, what is the next transformation? I was expecting you to write all those transformations on the test in order of operations. And I didn't really see that. Okay, so x squared. Then where am I going to?
You're changing x, you're going to the left one.
Exactly, and then?
And then you're flipping it to
Oh,
the
correct.
right one.
And then?
You're going down 4.
Okay, can anyone give me the vertex?
So -1, 4.
Okay, can anyone give me the vertex one more time? Careful.
H,
Exactly, but one more time. -1, comma? Yes. And that's it. That's what it is. H, comma, k. So What is the difference between these two possible situations? This one, I have to calculate what? The vertex. Here, for this one, I can only, or I only have to identify it. Okay, good. So now I want to go through the rest and graph this function. So number one, shape. What is it? Yes, indeed. Because the leading coefficient is less than 0, it has a maximum. Excellent. Very good. Number two, I don't have to do anything. Can anyone give us the vertex? Right. Number three, X-intercepts. Exactly. None. I'm not going to waste my time. Excellent. Number four, the Y-intercept. Exactly. I have to find f of 0. Let's find f of 0 together. Yes. 1 squared is 1 with minus in front, and negative 1 minus 4. Negative 5. Can anyone give us the ordered pair that we just determined as being the Y-intercept?
0, -5.
Excellent. And the last, I need two words here before I graph. Yes, the axis of symmetry. X equals -1. And since this function has a maximum, what is the maximum value? Max value of f of x is good. Indeed. Remember, x squared, x plus 1, flip, down -4. Without even graphing it, can anyone give me the range?
-4.
Careful.
No, it's negative infinity.
To -4.
To -4, because that's the maximum value. Perfect. Okay, let's graph it. Well done. I didn't do anything. You did. So I start with what? The vertex. Very good. -1, -4. It's right here. Then I continue with the axis of symmetry. And the Y-intercept, 0, -5. It's not really enough, but I'm happy for now. Just make it as symmetric as possible. We should find another point on the other side, maybe at -3 or -4, just to be as exact as possible. I'm happy with this for now. Any questions?